So I've had a number of questions on these limiting reactant and solution problems. So it's still a limiting reactant problem, but now we've put it in solution. So the real difference here is when you're in solution, we need to think about solubility rules. And a lot of you are saying, oh gosh, now I have to remember those solubility rules. So what we kind of want to do is I want to dissect this problem for you. And then I want to look at different steps so that you can then apply it to other problems. So when we're looking at this one says I have 3.53 grams of nickel 2 chloride. I've dissolved it in 350 milliliters of a 73.0 millimolarity aqueous solution of K2CO3. I know that's really small to read, but hopefully you can see that. And then it says calculate the final molarity of nickel 2 cation. Now, the key here is I'm just looking for molarity ultimately. That didn't work very well, molarity, and not the little m, capital big M. So when in doubt, whenever we have this, we notice it's giving me nickel chloride and it's giving me something else. So step one is always to balance the equation. So that's the first thing that we want to do. So I notice it tells me nickel 2 chloride, so I'm going to do that first. So I've got nickel and I've got chlorine. I know chlorine's always a -1. It tells me nickel is a 2. It's going to be NiCl. I'll come back and do states. So then that says added to the K2CO3. I think it actually told me it was potassium carbonate, and I kind of shortcutted it. So then what does it make? Well, I've got to change my partner, so nickel's going to hook up with CO3. We know that nickel is a +2 because it told us that, and I know that CO3 is a -2. And then I'm going to add to that my inside, so KCl. I know K is a +1, and I know that Cl is always a -1. Now, when I look at NiCl, Cl is one of those things, whenever it's attached to anything, it's automatically aqueous. So that gets a little AQ. K, anything attached to it is always aqueous. Okay, this one right here, that's a carbonate. We look at that little thing and it gets an S. Here we go, K, when it's attached to anything, is automatically AQ. That looks kind of funky. So I've got that. Woohoo! Now what? Well, I can go through, and if it's aqueous, what happens? It breaks apart, right? So I'm going to go ahead and I'm going to show that step. So this is going to be 2 plus AQ. Now there's 2 of these, so 2Cl minus AQ plus 2K plus AQ plus CO3 2 minus AQ. And that's going to go, this is a solid, so it stays together. And this is aqueous, so it breaks apart. Oh, I forgot to balance the equation. I should do that. Sorry about that. And how did I know that? I knew that because I'd had a 2 with a K plus on the left, so I had to have a 2 with a K plus on the right. Now remember, you want to lightly draw through your spectator ions, or anything that looks the same on both sides. So there's that 2Cl, 2K, 2K. So I'm going to write down everything that's left over. So there's that nickel ion, which we know we have to have because that says the final molarity of that nickel 2 cation. So if I hadn't gotten that, I would have known that I did something incorrectly. And then that's going to go to our solid. Okay, so that's my balanced equation. Well, that's great and all, but now I have a problem, right? Everything it gave me in the initial is for nickel chloride. And then I got these numbers for K2CO3, but I don't have those anymore, right? So what in the world am I going to do with that? Well, I'm going to find what I can to associate with ions that are part of those original compounds. So that's where it becomes important that you pay attention to what you have. So what I want to do is I'm going to find some moles. So remember when I said when in doubt, what do you always do? You want to find moles. So I have a balanced equation. Then once you have a balanced equation, you want to find some moles. Well, how am I going to do that? Well, I need to label that equation. So I've got, let's just rewrite it just for simplicity. Yep, it's a long video, but I want to make sure that it's very detailed and that you understand what's going on. Okay, so the first thing it gave us was this 3.53, and it said it was of nickel 2 chloride. So of the things that are left, the only thing I have left, like this right over here, was something new that we made. So nothing on the right, I can't deal with any of that. But over here I have nickel, and I have a carbonate. So nickel 2 chloride is going to be associated with the first one. And it says I have a 3.53 grams of the, and this was NiCl2. And I'm just going to go ahead and label that as NiCl2 for now. And ultimately, I need to find the concentration of the ion. So I'm going to put it like that so that I know what I'm ultimately looking for. Then it says I have 350 milliliters of a 73.0 millimolarity aqueous solution. So I'm going to go ahead and write that down. So that kind of looks like this carbonate, right? So I've got 350 milliliters of 73.0 little m, big M. And then all of this is actually of K2CO3. Okay, so I've got information. Now I've got two things right here for the K2CO3. So we're going to hope this works, which it's not working, so pause for a sec. Okay, so I've got the moles and everything. That's what I want to find. So I'm going to take this part right here, and I said I wanted to find moles. So that's all I have right now where I can find moles. So how do I do that? Well, I'm going to start with the given. So I know that this part right here with molarity, it's got something to do with moles, right? Well, right now I've got this milli part on there. So I'm going to come over here. Got 73.0 millimolarity. And that is of K2CO3. So I want it to just be regular molarity, right? So I know that there are 1,000 millis in 1 molar. Okay, so that gets rid of the milli part. But now I don't want molarity. I mean, I want just to get rid of moles, right? So I know that in molarity is the same thing as moles per liter, right? So big M equals moles per liter, which is the same thing as moles per 1,000. Ooh, running out of room. Milliliter, sorry. So I'm going to go ahead and just put 1,000 milliliters. So technically this thing is the same as this part right here. And then what else? I just want moles, so the other thing I haven't used yet is the milliliters. So I have 350 milliliters, so my milliliters cancel. So now the only thing I have left is moles. So when I do that on my handy dandy little calculator, I get 0.02555 moles of K2CO3. Now, I need to figure out for nickel ion. Well, I need to do what? Well, I need to find probably moles of that too, right? Or I need to at least figure out a limiting reactant. So how do I want to go about doing that? Well, I know that everything is a 1-to-1 ratio. So if I had moles, I could compare my moles to figure out which one is smaller. Right? Right. So what I'm going to do is I've got moles of that, so I'm going to go ahead and find my moles of the nickel 2 chloride. So I want you to try that, pause the video, and then come back and check your answer. Okay, so when you found it, we were given the 3.53 grams, so you just convert those grams into moles by finding the molecular weight. So here are my 2 moles. So now what am I going to do? Well, I need to determine the limiting reactant. So that's step 3. Now I'm going to rewrite the equation so that we can make sense of all this. So remember, the equation is what we've got after we took out all of the spectator ions. So here is my equation. Now I'm going to go ahead and put the corresponding moles. Now how I can do this is, of these 2, I just find the corresponding part. So remember we said anything with a K and it was soluble, so the only thing left after I take out the K is the CO3. So that's right here. So this one is 0.02555 moles. And there's your nickel, so that's 0.027238 moles. Now, the question asks the final molarity of the nickel to cation. So remember, we don't have molarity. And molarity, again, is moles per liter or moles per 1,000 milliliters. So what I still need to find is molarity. Now, to find how much is left, that was what we need if we're going to find a final molarity. So what we need to do is number 4 is the question you need to ask yourself is, which is smaller? So which of those two moles is smaller? Well, this one's got a 7 and this one's got a 5. So the CO3 2 minus is smaller. So that's the one that limits the reaction. So we got that. So now in step 5 we need to determine how much nickel is left. So we have to determine how much of the nickel ion is, oh sorry, this penmanship just kind of went out the window. Now remember, in this case everything is a coefficient. We have 1 and a 1 and a 1. So since it's a 1-to-1 ratio, we can just subtract the two. If it wasn't a 1-to-1 ratio, we would need to convert our CO3 moles into nickel moles and then subtract. But since it's 1-to-1, we don't have to do that. So we just simply take the larger one minus the smaller one. And we get our answer, which when I did it on my handy dandy little calculator, I got 0.001733 moles of nickel 2+. So that's how much is left. So once the reaction is completed, I've used up all except for this many moles of the nickel 2 cation. Okay, so I've got moles. You're right, we're not done yet. That's why this is a long video. So now we have to do the molarity. So now that we know how many moles are left, it's really easy to find the molarity. Because we have moles, we have some milliliters in the problem, right? So now all we're going to do is take the number of moles that are left. That's a point, sorry about that. So we've got moles. I'm going to go ahead, I could make this conversion, but I'm not going to because I don't want to confuse anybody. So I've got this milliliters. But remember, we need liters on the bottom, so there are 1,000 milliliters in 1 liter, so the milliliters cancel. And when I did that on my handy dandy little calculator, I got 0.00495, and it's a capital M because it's moles per liter. And when I started this whole thing a long time ago, I had 3 significant figures in all of my numbers, and there's 3 significant figures in that one. So when said and done, after this 14 minutes of fame, this is the final answer for the concentration of the nickel 2 cation. If you still have questions, please make sure that you ask.